Okay, let's talk about vacuum chucks for 2 minutes while I'm on a tea break. Okay, this is the chuck I use, which is extremely strong. Okay, it's just made out of a product called Polystone, which is a hard plastic. It's a machining plastic. Right, it's not nice to machine. It does melt very quickly, so you can see it's a little bit rough and jaggedy, but absolutely works perfect because it's non-porous. Some people make vacuum chucks out of MDF, which is totally useless. MDF, on the other hand, allows vacuum to come through. Alright, so it sucks through the MDF, which is absolutely useless for what you need for a small vacuum chuck like this. Okay, so this chuck is very simply made. There's a port here, which I've just drilled a hole through. So it runs through the chuck, and I've drilled a hole down, so it allows air to go down through this hole and out through this pipe, which is getting sucked. I've got a valve to switch on and off, and this is using a very small pump. So if I switch this on, you can just about hear that it's just sucking here. Okay, there's a very small amount of vacuum on this one. Sorry, very small flow, because it's only coming off a tiny little pump, which is there, which is a little Edward Speedy Vac. Okay, now I've got it set up so that the Speedy Vac comes through and it's teed off to a gauge. You can see the gauge is just bouncing there. If I switch the pump off, she'll go to full vacuum. It'll bounce for a couple of seconds and settle. And that's full vacuum on this pump. Okay, so for this job, I've made the chuck. I've got some alignment pins, which I use there and there. And this is actually creating the vacuum itself. And I've got an 8mm seal in here. Right, so this is a closed cell neoprene, and it's round. Let me just get a piece to show you. Okay, so it's a round section, closed cell neoprene. Alright, so where the inlet port is, you shouldn't have the, I've got the join here. The join should be the furthest away, so over here somewhere. But because I've been reconfiguring this all day for different jobs, that's where it is on mine. Alright, now it's got to be a clean butt joint, or even super glued together to give you a perfect seal, because if any leaks are on this, you won't get full vacuum. Let me just show you how it works. Now, just to make a point, this is no good with this amount of vacuum. It's no good for non-porous materials. So if you put on, for instance, a sheet of MDF, the air will just suck through and you'll lose your vacuum. All right, now for this job I'm using oak, which is non-porous, or it should be non-porous, and I can use it. I'm just aligning here and here because I'm not machining this edge. This edge is already machined. Okay, so all I'm doing is pulling the vacuum to hold this in place. Switch the pump on, or sorry, the air supply on, and there's my part in place. I'm just going to press it down. Now it's pulled up, and there we go. It's put in almost full vacuum, so we've got a very good seal there. Okay, now that part is sucked down to the chuck, so it's sucked down to here, and it works on, it's a common myth, it's not actually the suction that's holding it down, so it's not the air coming through here, is not sucking it down. What's happening, the vacuum chuck underneath is evacuating the air underneath, so taking away air pressure. So what happens then, you get normal air pressure coming down, air pressure force, 1 bar, which is atmospheric pressure, which is 14.5 approximately psi, pounds per square inch, pushing down on this. So that's as if you've got 14 pounds per square inch of this. These are a square inch, So it's 14 pounds on every one of these squares, pressing down. So when you multiply all that out, that is being held down by an awful lot of air pressure. Now, I can push as hard as I want on this, and that ain't gonna move. All right, so the air pressure is pushing that hard down to the chuck. To release it, so now I can actually machine all the way around this. I can go around here, I can go through the top. The only thing I can't do is cut all the way through to here, because that'll release the vacuum. All right, so if there's no vacuum, that'll just pop off the chuck. Just to prove that, if I turn the air off as if it's got a leak, yeah, and then if I was machining, and then it'll push away. I turn the valve back on, give it a little press to compress the seals down, and it's rock solid again. Okay, so I'm using the 8mm round. This is 8mm. All right, so what I've done is I've machined the grooves in here at 7mm wide, so I have to compress the seal into the groove. Okay, so that compresses in, gives me an airtight seal between here and here, and also on the bottom. So the rounded section presses against this side and this side, and I've machined it 6mm deep, so it's down 6mm to leave 2mm proud here. So if my wood is slightly warped, I'm still getting a seal before I press it down. Now, being rounded, this is why I used round and not square. When you press down, the seal can actually press down flush against the top of here, so it's not holding the part off the job, sorry, off the chuck. So that presses down nice and hard and holds it in place. So there's a big difference between that and this is a spoil board. Okay, so underneath here, this is a vacuum bed, but this is a massive version of this. Now this one uses 2 big pumps, and then it uses the MDF as a spoil board, which allows you, I don't know if you can see on my spoil board, where the sheets have been on top, you can see I've cut through, actually cut right the way through the sheets into the spoil board, which is here. The only thing with this is once you've done lots of cut out,